Okay, welcome back. We are doing trig substitutions, once again, part 2. I'm assuming that you are comfortable with drawing the reference triangle now that matches with the given situation. So in other words, you're seeing a radical of this form appear in the reference triangle. I'm assuming you've printed out the notes on iTunes and you're ready for part 2. So, okay, let's do some pattern recognition here. If you have the square root of a perfect square minus some variable expression here, notice that I'm going to rewrite this variable expression. I'm going to write it as 1 minus 3t whole thing squared, so that by pattern recognition on my reference triangle I can notice there's a quantity squared. Okay, quantity squared. I can say that basically x is going to be 3t in this pattern, and instead of a squared, root a squared minus x squared, that's the original radical of interest. So let's write that in. So square root 1 minus 3t whole thing squared. Okay, and then a is your constant, or it's a constant, it's the square root of your constant, so it's the square root of 1, which is 1. So you have to do a little bit of pattern recognition and decide, what's your a, what's your leg, and what are both of the legs of your triangles, right? Once you've laid this out, clearly, sine theta is opposite over hypotenuse, so 3t over 1. Then once you've laid that out, we can just clean that up and say that sine theta is 3t. And then I would keep laying out all important pieces of the puzzle, like the derivative of sine. Let's see if it'll let me scoot this down. It won't, so I'll lay it out over here. So the derivative of sine with respect to t is cos. So we'd have cos theta d theta dt equals and then the derivative of 3t is just 3. And then so you can manipulate that to say that cos theta over 3 d theta is equal to dt. And so we will need all of these things, for our replacements that we're about to do in a moment. And also, if you know that sine theta equals 3t, we can add another little tidbit that theta is inverse sine of 3t. And we will need all of these for our replacements. Let's move to the next slide. Actually, let's not move to the next slide quite yet. Let's talk about the whole psychology of the trig substitution. So we want to replace dt with whatever we said it was. What we had said dt was cos theta d theta over 3. Okay, so cos theta d theta over 3. We replace that. So big note to self. We replace dt, and then we're going to actually replace 9t squared. We're really replacing the 3t part of it. We know that 3t is equal to sine theta. So remember, we had kind of considered that as 3t whole thing squared. So you're really replacing the 3t with the sine theta. If you do that, you will have the integral square root 1 minus sine theta whole thing squared, and then times cos theta over 3, all of that d theta. And voila, this is what we want to operate on. So I'm going to hit pause as we go to the next slide. Okay, so we have arrived here. This 1/3, I'm going to pull that out front of the integral. Let me erase that a little bit. Okay, so pull that out front of the integral. So 1/3 integral. And then you may be recognizing 1 minus sine squared theta is cos squared theta. So let's go ahead and replace that. So note to self, replace, lots of replacements. So replace Pythagorean identity with a Pythagorean identity. And then we still have our cos theta d theta. Okay, then we keep cleaning. So we have 1/3 integral. Well, the square root of cos squared, that's what's going to take us back to cos. And then we're going to have cos times cos, which is cos squared. So we're going to have 1/3 integral of cos squared theta d theta. Now, big note to self, you want to replace this, but you do not want to replace it with something involving sine squared. You want to reduce power, or reduce the power of cosine. So we'll actually replace cos squared with a half angle identity, namely 1 plus cos 2 theta over 2. Note to self, 1 plus cos 2 theta over 2 is going to be our replacement. And I'll hit pause and we'll do that on the next slide. Okay, so now we keep cleaning. And style-wise, there's lots of ways you could deal with this integral. I like to pull the 1/2 out front. So you'll have 1/2, because you know that this could be split, like as 1/2 plus cos 2 theta over 2. So you could, in essence, factor out the 1/2. Let's pull that out front of the integral. And then you'd be left with 1 plus cos 2 theta d theta. Okay, now this part here shouldn't be bad to integrate. So we're going to have 1/6. The integral of 1 is just going to be theta. The integral of cos 2 theta is sine 2 theta over 2. But when you arrive here, I can tell you that you typically do not want, double the argument 2 theta. You don't want twice the angle inside the argument. So note to self, another replacement. And you want to sort of get that down to, rather than saying 2 theta, how could you get it to just say theta? So you want plain old theta, not 2 theta. So we can replace sine 2 theta with 2 sine cos theta. So then we're going to have 1/6 theta plus 2 sine theta cos theta over, 2 times 6 is 12, so that'll be over 12 plus c. Now, when you arrive here, life is good, but you have to go back to your original variable. So you have to think about g, what was theta? And g, what was sine theta? And you might even, I'll go back and look. Go way back to the original slide, see? Theta, and I wish I could highlight this. Yeah, I think I can in another color. Theta was, inverse sine of 3t. And sine theta was 3t. So theta we're going to replace with inverse sine of 3t. Go back and get your original variable, in other words. And sine theta itself was 3t. And cos theta, you have to look back at your original triangle. So let's just go ahead and look back at our original triangle together. Here's your original triangle, and here's theta. So clearly cos theta is adjacent over hypotenuse. So you have your radical piece over your hypotenuse. So you're going to have your square root of 1 minus, and your hypotenuse is just 1. So your square root of 1 minus 9t squared will be your cos. So your cos theta will get replaced with square root of 1 minus 9t squared. So you do your final replacement, getting back to your original variable of interest, which was t. So after all that sweat equity, I remind you, so we had 1/6 theta plus 1/12 2 sine theta cos theta plus c. So that's going to lead us to 1/6, again replacing theta with inverse sine of 3t plus, and then 2/12, that's going to knock out and cancel down to 1/6. So plus 1/6. Sine theta we said was 3t, and cos theta we said was square root of 1 minus 9t squared. And of course all of that plus c. Now if you arrive here, I'm pretty happy, very happy. You could keep cleaning though, like 3t and 1/6, like it's going to reduce down to 1/2. So you could go 1/2 t big square root 1 minus 9t squared plus c, and then 1/6 inverse sine of 3t. So you could keep cleaning that a little bit more to get to here. All right, hope that helps. And there will be each podcast for each trigonometric substitution, is very intricate and obviously takes about 10 minutes, so I'll do a separate one for each example. Good luck.